Hello guys, in this video we want to look at how to fill a trace table of a program written in assembly language. It's a typical question that you may find in one of the summative assessments, and without much ado, let's approach this question from an exemplar point of view. Now, you've been provided with such a table of instructions, meaning each opcode has been, rather the examiner has given you an interpretation of what each of them means. So once we scroll here, you realize we have the first instruction is LDD 100. What does LDD 100 mean? So we go back to our table, we look up LDD means direct addressing, load the content of the given address to accumulator. So we go to address 100 and we load whatever is in that address. 100 has 20. So we're going to the accumulator under instruction 50. So I've just taken a screenshot of this section so that it becomes easier to fill. So at 50 here, I will write 20. I write 20 like that. Then I do the next instruction, add 102. So add 102 means add the content of the given address to accumulator. So we go to address 102, we check what we have. Address 102, we have 1, a value of 1. So we add 1 here, and instruction 51 on that line accumulator becomes takes the value of 21. Then we do 52, we store this in 103. If you look at the lookup table, STO means store content of accumulator at the given address. So our 21 goes to address 103. So there we write 21. Sorry, I need to clean this and write it correctly. So we write 21 here. We write 21. Then we proceed to the next instruction, 53. Instruction 53, LDX 100. We go to the lookup table. What does LDX mean? Index addressing. Form the address from address plus the content of the index register. So our index register has 1, and we need to check LDX. LDX 100. So 100 plus 1 gives us 101. So we come and check what do we have in 101? 100. So we take the value and add it here. That's 53. So 53 will take the value of 100. Then we proceed on to 54, add 100. So we do addition of 100. What do we have in 100? 20. So our accumulator now has the value of 120. And then we do instruction 55, CMP 101. So we're going to compare CMP from our lookup table, tells us to compare contents of accumulator with the contents of the address. So our accumulator has 120 and CMP 100 is 101. So 101 has 100. So in short, we are asked, is 100 equals to 120? Of course, we know the answer is false. So let's see the next instruction. So there's nothing we are writing here. We move on to 56. Once we compare, what do we do? So at 56, we're told to JPE 58. What does JPE mean? JPE means following a compare instruction, jump to address if the compare was true. The compare was not true, so we are not going to do anything with 56. We move on to 57. So we go back to our instruction. What do we have in 57? JPN 59. So what does JPN mean? We go back to our lookup table. JPN, follow a compare instruction, jump to address if the compare was false. So our case here, 100 is not the same as 120, so the compare was false. We are going to jump to address 59. So again, there's nothing we are doing in 57, but we are writing. We move on to 59. And 59 was 59. Yes, we have jumped from 57 to 59. We INC index. So what we're going to do is INC is increment. So we're going to increment our index register. Our index register currently is 1. So by incrementing it at 59, we get to 2. So we just increase by 1. Continue to 50. That's 59. Continue to 60. 60, we are told to I hope time will allow. How many minutes do I have left? Oh, 5 minutes, we're still okay. So 60 LDX 98. What does LDX mean? Go back to your lookup table, index addressing form, address of address plus the content of the index register. Index register has 2. So our new address will be LDX 98. 98 plus 2 is 100. So we go to address 100 and we get 20. So this 20 goes to here in the accumulator. So we get 20 there. And then we move to instruction 61 and add 101. So we're going to take 20 and then we add 101, which is 100. So that takes us to 120. So our accumulator will have a value of 120. And then we move on to instruction 62. Instruction 62 is actually out. So meaning we are going to do an output. And since we are outputting the value of the accumulator, we go back to the lookup table, the output lookup table, this one here. So the value we are outputting is 120. So 120 represents X. So we go to where we have output here, and then we write X. So that's how you go about such a question. I hope this tutorial helps.